For what values of x does the graph have a point of inflection? So ask yourself, okay, so what do we look for here? We look for when f double prime changes sign. So if it changes from negative positive or positive negative, that's how we know we have a point of inflection, when the concavity changes, and the second derivative is where concavity comes from. So we got to find the second derivative, so let's do that. The first derivative would be 15x to the fourth plus 40x to the third. The second derivative is 60x to the third plus 120x squared. You know, this is the no calculator section, so you kind of hope that the numbers are going to work out nicely. You now factor it. 60x squared gets factored out. That leaves x plus 2. So the critical points that we need to look at where we think just maybe there's a point of inflection would come from x equals 0 and x equals negative 2. That's the 0 on there. Now I like to do a sign chart like this where I have my critical values and then I have my intervals that I'm going to look at. All right, and we're going to look at f double prime. So you can come back right here. Imagine plugging negative bazillion in here. This term is going to win, and it's going to be negative. So this is going to be negative. If you plug positive infinity, we're going to end up with positive. So we really need to know what's going on in this interval right here. I like to plug -1 in. That's the easiest thing. So let's come up here. 60 times -1 to the third power, that's just -60. And then, of course, anything squared is positive. So plus 120 times -1 squared is plus 120. That is positive 60. All we care about is the sign. So this is concave up there. The original function is concave up. So we have a point of inflection at -2 only. -2 only. That's where the sign changed. Didn't really care about analyzing that first derivative here.